This lesson we're going to be talking about operations with radicals. So the other day we learned how to simplify radicals and reduce radicals. We're still going to need those skills, but today now we're going to be moving on to adding, subtracting, multiplying, and dividing those radicals, or we're just going to be focusing on square roots today. So first, to add or subtract square roots, the first thing you do is simplify your square roots as much as you can. So what we learned to do the other day. And also don't forget, if there's a number out in front of a square root like this, like if we had 7, square root of 18, we had this 7 here. When we're multiplying, we have to not forget to multiply that 7 by whatever we get when we're doing our simplifying. So don't forget about any numbers in front you need to multiply. And then once you have all your square roots simplified down as much as they can, then with any terms that have the same number under the square root, or like square roots, if we want to think about it in terms of like terms, then you can add or subtract the numbers out in front of the square root, and the square root stays the same. So for, let's say like square roots, again, only like square roots only. If we had a square root 2 and a square root 3, we could not add those together. For like square roots, you would add or subtract the numbers in front of the square root. And the square root stays the same. Also remember, if we have like square root of, we'll say square root of 3, that's the same as saying 1 square root of 3. So if there's no number written in front of that square root, that's an implied 1. Okay, so if you look at example 1, add or subtract. So first things we need to do is reduce our square roots as much as we can. So I have a couple numbers out in front, so I don't want to forget about those. At least 7 times. Then square root of 8. So remember, we're looking for a perfect square. Remember, our perfect squares are 4, 9, 16, 25, 36, 49, 64, 81, 100, etc. Going on. We're trying to find the biggest one of those numbers that can go into this radicand here, the number under the square root. So in this case, 4 is the largest perfect square that can go into 8. And the square root of 4 times the square root of 2, because 4 times 2 is 8. And now we know the square root of 4 is 2, because that's a perfect square. And there's nothing more we can do with the square root of 2 there, so we're stuck with those two. Okay, then moving on. So now we have plus 5 times square root of 2, because we can't reduce the square root of 2 anymore. Then plus this 2 times, and then looking at a square root of 12, again, we're trying to find the largest perfect square that can go into 12. 4 is the largest perfect square that can go into 12. So square root of 4 times the square root of 3, because 4 times 3 is 12. Square root of 4 is 2, and we can't do any more with the square root of 3. And then we have a minus a 6 square root of 3. Okay. So now the numbers that are not inside a square root, we can multiply those together. So I have 14 square root 2 plus 5 square root 2 plus 4 square root 3 minus 6 square root 3. And so now remember, we can only add or subtract our radicals here if they have the like square root to the same number under the square root, which means I can only add together these two terms that have a square root 2. And I can only add together these two terms that have a square root 3. So we'll add the numbers out in front. 14 plus 5 gives us 19. Square root comes along, so 19 square root 2. And then we have our square root 3's. We have a positive 4 minus 6, which gives us a minus 2 square root 3. Remember, whatever sign is in front always goes with whatever comes after it. So it's a positive 4. And then the square root 2, square root 3, they are not the same number under the square root, so we cannot combine those any further, and this would be our final answer. Okay, let's do one more example. So letter B, square root of 2 plus square root of 8. So remember, this is like a 1 square root 2 plus, and then square root of 8, largest perfect square that can go into 8 is 4. So we have square root of 4, square root of 2. Square root of 4 is 2. And we're left with our square root 2 there. Okay, so then we have 1 plus 2, because they're both square root 2, so we have 3 square root 2. Okay, I want you guys to go ahead and try C and D. Alright, and I'm moving on to multiplying square roots. So when we're multiplying, as long as we have non-negative numbers, we can use the product rule. So if we had like a square root b, so a is just a number and b is just a number, times c square root d, then with multiplication, we can multiply the numbers that are outside the square root together, and we can multiply the numbers that are inside the square root together under one big square root. And then you always need to see if you can simplify at the end once you do your multiplication. Okay, so we look at example 2a. So multiplication, we can take our numbers out in front. 2 times 3 is 6. Then we take our numbers under the square root. 2 times 5 is 10. And then to see if we can simplify, we need to see if any of our perfect squares can go into 10, and none of them can, so that means this is simplified as much as we can go. Okay, I want you guys to try letter B and C. Go ahead, try B and C. Okay, so now moving on to dividing. So you can use a quotient rule. It's similar to the product rule, where if we have a square root b divided by c square root d, then we can divide the numbers that are not in a square root, and we can divide the two numbers that are in square roots. And then always use simplify. Okay, so we find the quotient. Square root of 75 divided by square root of 3 would be the same as saying the square root of 75 divided by 3. So 75 divided by 3 is 25, and the square root of 25 is 5. Okay, I want you guys to try B and C. Actually, I'll do B with you. I'll do B. So square root of 90 divided by square root of 2 would be the same as saying square root of 90 divided by 2, which is the square root of 45. Then we need to see if any of our perfect squares can go into 45. 9 is a perfect square that can go into 45. So the square root of 9 times the square root of 5. Square root of 9 is 3. So we have 3 square root 5. Alright, I want you guys to go ahead and try letter C. Okay, so one little extra thing that comes into play when we have fractions with these square roots is called rationalizing the denominator. This is just when, if you have a denominator that has a square root of a natural number that's not a perfect square, meaning you have a square root that you cannot evaluate in your denominator, then rationalizing the denominator is when, you need to get the square root out of the denominator. And so to do that, first you can simplify as much as you can. Then you're going to take whatever that square root is that's trapped in the denominator. You're going to take that square root and you're going to multiply it in the numerator and the denominator. So take that square root that's in the denominator and multiply it by the numerator and denominator. And then, of course, simplify at the end. Okay, so let's take a look at letter A. So we have 15 divided by square root of 6. So right now, 15 is not in a square root, 6 is in a square root, so we can't do any simplifying right there. So we're trapped with this, or we're stuck with the square root of 6 in the denominator there. So rationalizing the denominator says I take whatever that square root is, so square root of 6, multiply square root of 6 in the denominator, multiply square root of 6 in the numerator. And so here, 15 square root of 6, we cannot multiply those together because 15 is not in the square root, but we can do 15 square root of 6 in our numerator. And then our denominator will have the square root of 6 times 6, which is 36, and the square root of 36 is 6. So now the square root is no longer in the denominator. And we can do one more thing to reduce, because if we look at our numbers not in a square root, we have 15 divided by 6, and those can both be divided by 3 to reduce that a little bit. Or you can do 15 divided by 6 in your calculator and do that math, enter, enter. But this would leave us with 5 square root of 6 over 2. Alright, let's look at letter B. So letter B, we can do some simplifying here with these fractions. Again, if you want to just type in your calculator, no square root, but 35 divided by 10, and math, enter, enter, that will give you your reduced fraction, which would be 7 over 2, so square root of 7 divided by 2, which we can split up as the square root of 7 divided by the square root of 2. Then to rationalize the denominator, we take whatever that square root in the denominator, multiply by square root 2 in the numerator and denominator. Now everything here is in a square root, so we can multiply all these numbers together. So we'll have square root of 14 in the numerator, and then square root of 4 in the denominator, but square root of 4 is equal to 2. Okay, and again, since the 2 is not in a square root, we cannot divide 14 by 2, and there's no perfect squares that can go into 14, so there's no more simplifying we can do. So square root of 14 divided by 2 is your final answer. Alright, so if we look at letters C and D, so again, we can do some simplifying here to start. We could even simplify this square root also. The more simplifying you do at the beginning, there's just smaller numbers you'll have to deal with later on. So I want you guys to go ahead and try C and D, rationalizing the denominator. So the goal is to have no denominator, or no denominator with a square root. Alright, now there's just going to be some quick check questions and a self-assessment, and then bring any questions you have to the Google Meet.